So hello everyone, welcome back to our channel. Today we will be continuing with our Verilog series. The topic of the day is continuous assignment. So now let's begin. First of all, what is continuous assignment? In Verilog, there are two major types of assignment, continuous and procedural assignment. As we have discussed before, there are two main categories of data type in Verilog. The first one is wire and net type, and second one is of reg type. Continuous assignment is used for net type data. And in further videos, we will be taking the look at the procedural type assignment, which we will be using for reg type data. Now, let's take a look at continuous assignment. Continuous assignment is used to drive values onto net like wire using the assign keyword. Simply put, we use the keyword assign to provide value to a net type data, such as wire. So, what's the use case of continuous assignment? As we have discussed, the wires need to be continuously provided some values. Assign keywords does that only. It can be used to model combination logic as the anything which is ever written in RHS. It can expression we will or a value that will be continuously monitored, and if there are any changes in RHS, that will be reflected in LHS. So we will be taking a look at example in the further slides. But one thing you need to keep in mind regarding continuous assignment is that it cannot be used with reg. As for reg, we have procedure assign. Now, before we take a look at the example, let's see some rules. For assign keyword, what is allowed on the LHS? We can simply have a plain wire, a scalar or vector wire can be used on LHS. That is something like assign A is equal to B. Here, whatever value of B is present, that will be provided with. And if further the value of B changes, then that changes will automatically be reflected in A. It's like continuously monitoring B, and all the changes are reflected in A in continuous assignment. We can also select a part of the wire through bit select. That is, if we only want to assign the second bit of this vector bus, then we can also do that. That bus 2 is equal to inf bit. This is also supported via assign keyword. The next is part selection, constant part selection of a vector net. Earlier we selected a bit, now we can part select. That is, we can also have multiple bits that also can be assigned via assign keyword. Then this is constant index part select. This is the operator which can be used to variably select range. We will be having a separate discussion on this operator specifically, as it has a good amount of use case when we are working with multi-bit mux. Last but not the least are concatenated or nested concatenation, that we can assign a combination of two bits. We have two wire each of 4 bit, and that can be directly assigned providing the value of x. Now here the upper 4 bits will be assigned to wire A, while the lower 4 bits of x will be assigned to B. I hope it's clear. What are the 5 things that are supported on the LHS of assign? Let's quickly recap. The first one is net, simply. Second one is a bit selection of a net. The third one is constant part selection. Fourth one is constant indexed part selection of vector net. This operator, it simply selects variably the range. That is, it will start from 4 and select the 4 upper bits. It is same as writing like this 7 to 4, 7 to 4. These are same. But what the further use case of this operator? Plus colon operator, we will be discussing them in future. And the last one is a concatenation or nested concatenation is also been supported. I hope this makes it clear. Now, what is allowed on RHS? On RHS, we can have any constant, nets, or even reg type data. RHS, there are no such specific rules. Whereas we can have any kind of expression, variable, whatever, it's providing some value. and that value will be continuously supplied to the LHS. We can even have expressions. We can have a comparison like we can have assign a is equal to x plus y. So this is an expression. X and y can be raised as well. Then we can also have the ternary operator, which we have discussed earlier. We will also be using to use this ternary operator while designing a mux. The concatenation and function calls, as we have saw the use of concatenation operator on LHS, on RHS also concatenation operator can be used, while the replication operation can also be used. Hence, these are all the values that are supported on the RHS. Now, let's take a look at few of the examples. The first example that we have here is an AND gate. Now we are all aware about the basic structure of any module in Verilog. We have the module keyword, then the module name, then the input and output wire A, B, C, A, B, Y. Now here we use the assign keyword and assign Y is equal to A and B. So whenever A or B is changed, simultaneously Y will be updated. So this is how we can model AND gate. Now here I have an assignment for you all. You should try to similarly make model for OR gate, NAND gate, NOR gate. All the gates you should try. And if you face any difficulties, you can post it in comments. We will be happy to help you. The next example we have here is of half adder. So before we take a look at the half adder code, I want you all to first of all try to remember what were the expressions for half adder was, or try to draw the circuit of half adder in your notebook. Once you have done that, then please proceed with the video. Okay, so I hope you have tried to remember the expression or you have drawn the circuit in a notebook. Now try to match your answer with this code. For a half adder, we have two input ports, that is input wire A, input wire B. Then we have two output ports, output wire sum and output wire carry. Here I have not declared any bits, so by default all of this would be a single bit. Now I use the assign keyword, assign sum is equal to A XOR B, as this is the expression for sum, and for carry we can write it as A and B. So if you have drawn the circuit, then you must have used one XOR gate for the sum output and one AND gate for the carry output. This is how. So we are just modeling that in Verilog via continuous assignment. So I hope now you can see how we are using the assign keyword, the data types, and the operators to actually model whatever circuit we have in our mind via Verilog. Here, the assignment you all will be having is you will need to try to create a full adder. Half adder code I have shown. You should try to create a full adder code. The next example we have here is a mux 4 down to 1. So for a mux, we can have 4 input lines and there will be 2-bit select line. As we have 4 input line, to select 4 input mux, we have two select lines that we are modeling using a 2-bit select line, and we have one output, a single bit output. Now if you don't remember the use case of ternary operator, what it does is it checks the condition whatever we have written here. Then if the condition is true, then the first part is selected as the output. If the condition is false, then the second part. But here you can see that I have written so many ternary operator. So this is in case of nested ternary operator. How will this work? First of all, the select line will be checked. If the select line value is 0, 0, then input 0 should be assigned to output. This also shows the use case of ternary operator as well as a complex expression that can be used to provide values to a wire via assign keyword. So how will this work again? The first of all condition will be checked. If the select value is 0, 0, then the input 0 will be provided as output, which is correct. Now if the condition fails, that is the select value is not 0, 0, then it will come to false. So once it comes to false, it will check that if is the select value 0, 1. Yes, if the select value is 0, 1, then 1 will be provided as output. If this condition falls, then it will go to check in the third condition. The third condition we have here is the select line equal to 2, then input 2 will be provided to output. If this also fails, so it must the select line value can only be for conditions 0, 1, 2 or 3. If the value is not 0, 1 or 2, then it has to be 3. Hence, in the last case, we will be providing input 3 as output. I hope this makes it clear that how can we use assign keyword, what are the key rules regarding the assign keyword, what can be provided on LHS and what can be there on RHS, and also what are the specific use case for via which we can develop complex circuit or we can intermediately use whatever logic we require. If you have any doubt, please feel free to post them in comments. Thank you.